Good evening, everyone. In the last session, we discussed about the one of the important example on. Okay, so now observe carefully. We identify the tree set information. Now we need to move on to the another important information, queue related. Whatever we discuss here, the queue interfaces here. We need to identify the what are all the implementation classes we are having. Okay, so observe carefully how this particular the queue is implemented internally. Now we'll discuss about the implementation class here, something like a priority queue. Okay, priority queue is the implementation class of this particular queue interface here. Now, so what I will do here, I'm going to create the same class. So this particular class I'm trying to create here, and here priority queue demo here. Now, whenever I'm trying to create this particular priority queue demo, now what we will do, basically here I'm going to create the priority queue. Okay, so priority queue. So this is the one of the implementation class of this particular queue interface. Now, what I'm trying to pass here. So again, we'll try to discuss about the same double data type here. The element like generic type I'm trying to pass as a priority queue. Here I'm trying to give as a PQ, and the priority queue I'm going to give. Now, if we observe how many constructors we are having here, we are having lot of constructors we are having. Getting the point. Here now you can see first one is a default constructor, and second one is a collection is expecting the parameter, and another one is a comparator we are having, and fourth one is a initial capacity. Okay, so now another constructor, now you can see it is expecting one more priority queue objects here. Getting the point. Another constructor it is expecting priority queue. So first what I will do, I will try to explain this particular priority queue constructor. Priority queue constructor I'm going to provide. Now let me close others. Okay. Now I will open this particular class. Now we'll see. So what are the different constructors we're having? Before going to discuss about this particular constructor, we need to understand the implementation class. Now, if we observe carefully the particular hierarchy. So this hierarchy is important here. First, we'll try to discuss about the collection interface. Okay, collection interface. So collection internally, it is discussing about the interfaces. So it is trying to extending this particular list interface, and another one it is extending this particular set interface. Now another one is extending queue interface. So list is implemented by the two classes we discussed so far, array list and linked list. Okay, so set internally it is extending like a sorted sets. So SOS instead of this SOS, I can write a SS, and internally it is extending navigable set. These are all the interfaces. So once it is implemented, now if we observe carefully, so set is implemented one class, something like hash set. Okay, and hash set internally is extended by the linked hash set. Getting the point. Linked hash set we discuss here, and this navigable set is implemented by only one implementation class, that is called tree set. Okay, this is the tree set we so far we discussed. These are all the interfaces we discuss here, and these are all the implementation classes for this particular list, and these are all the implementation classes we discussed inside this particular set interface. So finally we identified hash set, how it is working, linked hash set, how it is working, and tree set, how it is working internally, we identified here. Now we need to discuss about the queue related information. So this particular class, now it is implemented, sorry, this particular interface, now it is implemented by priority queue, something like a PQ I'm trying to provide. So this is the priority class. Now internally, priority class is having one abstract classes. So this is the abstract classes are very important. For these two classes, what is an abstract class? Abstract list. Okay. For this particular set related classes, we are having abstract set. Okay, and the same way for this particular queue related, we are having abstract queue. Getting the point? This is very important. We need to understand here. We are having abstract classes and normal classes and interfaces. So these are all the three combination we are having inside this particular collection framework here. Okay, this is important. And collection interface is implemented by one of the abstract class called abstract collection. So this is the abstract class, and AL is also one of the abstract class, and abstract set is also one of the abstract class, and AQ also one of the abstract queue. Okay, these are all the abstract classes, and these are all the concrete classes. First concrete class, second one, and these two are the concrete classes, and this is the one more we are going to discuss here. Okay, this particular class internally it is extending like this, and these two classes internally it is extending like this. Not two, this is also it include three classes. Okay, so here three classes are extending abstract set, and these two particular classes are extending abstract list here, and all the abstract classes are extending by default this particular abstract collection. Okay, this is the agenda. We need to understand how this particular collection framework is working internally. Okay, now what I will do here, I'm going to discuss about the priority queue, and the priority queue is the implementation of this particular queue interface. Now we'll discuss the one more interface we are having. Later we'll discuss about the another important information. Okay, so back to here. So anyone having any questions so regarding this diagram? So this diagram will give you the all the collection related information, because collection is the part 1. Okay, and map is a part 2. So once the part 1 is completed, we'll move on to the part 2, how this particular part 2 is implemented internally. So few of the classes we already discussed here, but first we'll move on to the interfaces. Later we'll come with the implementation classes. So one more time we can discuss about the particular implementation classes, how it is going to work. So anyone having any questions?
So, sir, this abstract collection is the parent class for all these abstract class.
Yes, correct. Because each and every the sub abstract classes are like extended from this particular abstract collection. Okay. If we don't have anything, now what I will do, I'm going to like clear this particular diagram, and we'll move on to the implementation class called priority queue. So if you see the abstract queue we are having it, and if I'm trying to extending this, now internally it is extending from abstract collection. Internally it is extending from abstract collection. Same way, whatever the classes we are going to have, so all the classes are going to extend this particular abstract collection. Okay, so this is very important information. We need to understand how this particular abstract collection is having internally, and the same way all the specific classes are like extended based on the specific interfaces. Okay, we'll come back to here. Now we'll go for the same class here, priority. The priority queue is internally what is doing here. Basically, this is the one of the implementation class here. Getting the point? Priority queue internally, it is implementing this particular class. So if I'm going to show you this, now here you can see it is implementing the queue interface. Getting the point? It is implementing here. So abstract queue is the one of the abstract class. This abstract class internally, it is implementing from this particular queue. So we discussed the queue related methods. What are the queue interface related method we are having? Now you can see here we are having. Okay, these are all the methods we are having. So specific method. Getting the point? This is important. These are all the specific method which are available inside this particular queue interface. By default, this queue interface internally, it is extending from the again collection interface. Okay, now observe carefully what we need to understand here. Queue is a one interface, and it is internally extending this particular collection. So collection, whatever the collection methods we are having, the top one. So these are all the collection related methods. We'll try to reuse this particular collection method inside this particular queue interface. And now the queue is having some of the separate like a specific method. Like we already copied this all the methods into the our like a text file here. We'll discuss about the one of this particular method, how it is going to work. And so if you are not understanding the purpose of this particular method, try to read this particular documentation. Will give you the how this particular the method is going to behave internally. Okay, this is important. So just it is declaring this particular method. The implementation, this particular each and every method implementation is done under this particular priority queue class. So if I'm going to check this, so this particular peak method. So now you can see it is containing method body. So far here it is does not contain any method body. So just we are declaring. So this is one of the abstract method. This abstract method is implemented here. Okay, so this is the method is implemented internally. Now what I am doing is, so this is the one of the queue array. Now you can see here it is showing the particular array brackets here. It is trying to load the first record. Now you can see, now you can observe it is the object array. Same way, what we identify inside this particular array list, same way here we are defining one of the object array. Okay, now we'll see what is the default capacity we are having. The default capacity we are having 11. So far, how many elements we can insert here? We can insert by default 11 elements. So once 11 elements are completed, what happens internally? Automatically, this particular object array, it will grow. Getting the point? Automatically, this particular object array internally, it will grow. No need to write any explicit code, because this is the main advantage we are going to get whenever we are discussing this particular collection framework. So any class, whatever the particular classes we are writing here, internally we are having the feature automatically. It will increase and it will decrease based on our requirement. So it is increase and it will decrease the size. Okay, so back to here, we identify default capacity. So some of the capacity we are having 10, and some of the capacity we are having 16, and some of the capacity we are having 11. So this is, we need to understand, so which classes we are having 10 and which classes we are having 16, and which classes we are having 11. So these are all the important. Now same way, whatever the comparator we identify inside this particular tree set, same comparator we are having this particular declarations here. We'll see how it is implemented here. Now we'll discuss this particular mod count, because this is the internal the variable declarations here. We are not going to use outside of this particular priority queue. And so this is the default constructor. Okay, this is the default constructor we are calling. Whenever we are calling this particular default constructor, what is the constructor we are calling it? So with two parameters. Okay, with two parameters we are passing here. Like first one is the default initial capacity. Second parameter we are passing as a null. And this keyword, so this is very important. This keyword is used to call the, so one more constructor which is expecting two parameter. First parameter int and second one is null. Okay, now you can see this is the one more constructor we are having which is expecting initial capacity. So once the initial capacity we are passing, again we are calling the same two parameters constructor. So far we discussed the two constructor. First one is the default. Second one is one parameter is expecting. The one parameter we are going to pass as a capacity. Like we are going to provide explicit capacity. And after this, so this is the one comparator we are going to pass. Okay, one comparator we are going to pass. And now you can see this is calling the initial capacity and comparator. Now what you understand here? So we are passing the initial capacity and this null which is expecting comparator object. Okay, which is expecting this particular comparator object here. This is very important, we need to understand here. Now we'll come back to here. We identify this is the one more priority comparator we are having, and this is expecting comparator we can pass as a parameter. Now finally this is calling internally one more parameterized constructor. So two parameterized constructor. So this is the final constructor it is going to call, is expecting initial capacity or it is expecting comparator object. Okay, this is the fourth constructor we are discussing here. After this and one more constructor we are having, we can pass collection object as a parameter. Okay, so this is how we are calling the add all method, remove all method, retain all method. Same way we can create a one more collection and we can pass it to this particular constructor of this particular priority queue. So five constructor we are having, and another one constructor is expecting a priority queue. So the same class, whatever the priority queue we are going to create, same class we can pass as a parameter. So this is the one more constructor. So around six constructor we are having, and another constructor now you can see sorted set. Okay, sorted set related object we can pass. So something like the hash set or linked hash set, whatever the classes we are having, we can pass internally. And so around seven constructors we are having inside this particular priority queue. So each constructor will do different operations internally. Okay, so four or five constructors are doing the same operations, but a few of them are, few of the constructors are having internally with the specific operations here. Okay, so this way, the constructors we are having inside this particular priority queue. Now we'll discuss about the add method, because add method is coming from the collection interface. How this particular add method is going to call internally inside this particular priority queue. So far, I'm not passing any constructor. I'm calling the default constructor. By default, we'll get the default capacity as 11. So far we can insert 11 values inside this particular priority queue. So now observe carefully. I'm calling the add method, and I'm trying to pass this particular double value. Now we'll see how this particular method is going to work. And so first I'm going to print this particular statement here, how it is going to print here. Now you can see, so priority queue we are having, and it is terminated, the value it is printing 12.4, because the toString method, whatever the toString method where we implemented, the toString method we implemented under the abstract collection, because abstract collection is a super class for all the subclasses whatever we are implementing here. Because of that, in the common place, getting the point, instead of defining the same toString method in the each and every class, in the common class we are trying to defining here. Because if we observe the hierarchy, because the classes hierarchy, topmost class is the abstract collection, and it is divided into the multiple classes. So it is a abstract list and abstract set, and so now we are discussing about the abstract queue. Abstract queue. These are all the abstract classes here, and this subclasses like sub abstract classes having, this is the super one of the abstract class here. Okay, so here we implemented the particular toString method, and whenever you're trying to call any subclass, because abstract is internally implemented by these two classes. First one is array list, second one is linked list, and hash set is implemented by this particular three classes. So first one is hash set, and linked hash set here, and another one is tree set. Okay, same way this abstract queue is implemented so far, this particular priority queue. Okay, priority queue. We'll discuss what are the other classes we are having, which is extended from this particular abstract queue. Okay, now see, this is only the classes related hierarchy. So this is related only the classes hierarchy. If I'm going to include the interfaces, it will different here. So far we discussed the interfaces and classes hierarchy, how it is implementing. Now understand here how this particular toString is working. Any class. So for this particular any class, if I'm going to call the object references directly, it will call this particular abstract collection toString method. Okay, the toString method is having array bracket, and will insert the value, and it will close this. So this is the structure we are having. If you're trying to write your own toString method, you need to specify in the specific classes here. Okay, the toString we already discussed it. Just I'm trying to giving the, so like one more time the explanation how it is going to work, the toString internally. So back to here, we need to identify how this add method is going to work. Okay, this is the one of the important we need to understand. So then only we can understand how this priority queue is implemented internally. Okay, I'm calling this particular add method. We are calling this particular double. It's converting into the double value. Again, I'm calling this particular add method. So far, observe carefully, offer method we are calling. So offer method we are calling. Okay, now we need to understand the add method as well as the offer method, what it will do. Now you can see if it is null, it will try to throw in a null pointer exception. So whatever this particular E we are going to pass as a null, we'll get as a exception here. But some of the object we can pass null. Getting the point? So that we discuss hash set here. This particular object we can insert the null, but inside the priority queue we cannot insert the null. It is throwing in a null pointer exception. So we did not provide the null object. We are moving into the mod count. So what is the size right now? 0, because this is the first record we are inserting. After this, so I greater than or equals to q dot length. Okay. Now what you understand, this particular condition will satisfy or not? It will satisfy, because right now size is 0. We did not insert any record into this particular queues. So it is 0. Okay. Default to it is loading as a 11 here. Now you can see it is trying to load this particular default record. So we are getting as a length as 11. Now, so it is not satisfied this. Okay. I value we are having 0. So this particular I value, you can see where we are having 0. This value, it is not a greater than value. Okay. Now you can see grow is not calling internally. Okay. What we are doing is, so we are calling one method called shift of method. This method we need to understand how it is implemented internally. Now I'm trying to move inside this particular method. We are checking comparator. So we did not provide any comparator as of now. So it is returning null here. So if it is not there, we are moving into the comparable section. Okay, comparable. Now we'll see how this comparable is working internally. So what is the queue we are having? It is containing all the objects as a null, because this is the default capacity 0 to 10. 0 to 10 is nothing but 11 record we can insert here. So far we did not insert any record. This is the first record we are trying to inserting. And what is the record we are inserting here? This is the x1. So now if you see 12.4 and k value 0. Now what you understand, in the 0 index location we are going to insert this particular the 12.4. Now we'll move on inside this particular shift of comparable, how it is implemented internally. Now observe carefully. This is the object ES I'm passing, because the object we are going to store into this particular ES only. Now X value I'm converting into the comparable, and K value something like 0 we are getting. The while condition, getting the point? The while condition will fail. If it is fail, simply we are storing this. Simply we are storing this. So this is important here. Okay. Now we identify this. So whenever we are identify this, now what we are doing is, in the 0 index location, because ES is our object references, here we are passing it in the 0 index location. The first value we are inserting as a 12.4. So this is completed. Okay. Simply we inserted the first record. We are going back to the returning true. Okay. Now it's completed. Now what I will do, from the second record, this is important. What happens internally? And one more, the same add method I'm calling a, okay, not a PD, it is a PG. PQ. So PQ dot add method we need to call, and something like 45.2 I'm trying to pass. Now we need to identify this, how it is going to work. So we'll try to add multiple records here so that we can understand. So how it is going to work internally. So 5 records are enough. Okay, so from the second record onwards, we need to debug the code, because first record, now we identify how it is going to work internally. From the second record, we need to identify how it is going to work. Now observe carefully, we are calling the second record here. Now offer method we are calling, and E is not a null, and size method. So with this particular value, it is not going to match internally. Okay. So this will not match, and we'll directly call this particular method called shift of method, and we are checking the comparator. So for the comparator is null. We'll go back to the comparable, and I'm trying to converting into this. So k value, what is the k value right now? Something like 1. Okay, something like 1. And this object as of now, only one record is inserted inside this particular object elements here. Okay, this is the priority queue. So we can discuss as a priority queue. The priority queue internally, it is trying to store in the object array only. Now, when this particular condition will satisfy, when this particular condition will satisfy, now what is doing it? Now we need to understand here. Getting the point. So what is the parent we are getting? 0. Okay, the parent is 0. Now once the parent is 0, now what I'm doing is I'm trying to load the record first. So using this particular object to array, I'm loading the record. I'm trying to set into this particular E. Now we'll identify. So we are having this particular E as a something like what is the value? 12.4. Okay, after loading, I am calling this key dot compare. Key dot compare to. Now again, what I'm passing here, I'm checking because compare to method will return integer like integer values. So either it will return -1 or +1 or 0 values. So negative, positive, and 0 values it will return. Now what you need to understand here? What is the key? What is the key we are passing The key will contain 45, and we are trying to check with this particular E, something like 12. So now which value we are going to get here? So this is important. If it is greater than or equals to 0, like when the positive value will get, we'll try to break this. Okay, whenever we are getting this particular positive value, we are getting break this section here. Now you can see, first I will check this, what is returning here. What is returning? Positive value. Getting the point. So whenever it is trying to return the positive value, now what you need to understand here. So it is trying to break this particular loop here. Now you can see, so it is breaking directly. We are coming out here. Okay. So for this particular second record, we are trying to come out of this. Now, whatever the key we are having 45 in the first index location, we are inserting it. Now you can see this particular yes now will contain the 2 records. We'll debug one more time for the third record how it is going to insert here. So this is the third record we are calling one more time. Now let me go back to the same offer method, and we'll go back to the shift of method, and here the comparable. So I think here we can put a breakpoint. Directly we can come to this particular line number. So instead of coming one by line, directly we can come here. Okay, what is the key right now? This particular key 2. Second value I'm getting. And what is the X we are having right now? 78.3. And this is the object array. We are going to store the element into this particular object. Now, what you need to understand again, so we need to discuss about this particular parent. So what is the parent we are getting? 0. Getting the point in the 0 index location. So what is the value we'll get? Again, 12 value. So now if you see this particular E, you will get as a 12.4. So once we are getting this particular 12 value, we are comparing one more time. We are comparing one more time here. So what is the K value we are having right now? The X value 78. Again, we'll get the positive value. Again, we'll get this particular positive value. Okay. So if you see one we are getting, so this particular loop again it will break. So once it is break here, we are not going to get anything. If it is not break here, so observe, if it is not break here, what is the condition is happening? So that will go to the line number 664. What we are doing basically, so whatever we are having this particular E, now I'm replacing with this. So where I'm trying to replace it? In the K index location. What is the K right now we are having? Something like a 2. In the second index location, whatever the value we are going to load, this particular value is going to replace here. So once it is replaced here, again we are making the parent. Again we are making this particular parent. So parent, one more time this particular loop will repeat. Parent, one more time this particular loop is going to repeat. Again we are trying to check this particular compare to. Same thing. So if you see, we are making the position change here. Getting the point? We are trying to do the position change. So we'll see any one of the example is going to match or not. Later we can identify, because for this example also it is trying to break this. So we are inserting in the third index location. So this is the value we are having. So now, okay, fourth value. Okay, fourth value, same it will get to positive value only. But we'll see what is the parent we are getting. Again, the parent we are getting as a 1. Again, we are getting as a parent 1 in the first index location. In the first index location, 45, I hope I'm thinking. Uh, 45. Yes, the 45 value, it is loaded. Now, this A will contain the 45. The key is contain something like a 96 here. Now, what happens internally? Okay, now what happens internally? So again, it will check. We are going to get positive value. Again, it is breaking here. Now we are trying to store. Now what I will do here, I will modify these records because we provided as a sequence order. Now if I'm going to modify this, first record I'm going to insert as a 96 here, and here I'm going to insert after 78. Now we will see how it is going to work internally. Getting the point, how it is going to work internally, right? So this is important because so we given the lowest to highest. Because of this, we could not identify how this priority queue internally it is working. But now what I'm doing here, I modify some random values. Now we'll see the magic how it is implemented inside this particular priority queue. So observe carefully. I'm trying to run this example. Okay. So this is the priority queue. First record I'm trying to insert here. Now what is the K? We are going to get as a 0. So here you can see 0 we are getting here for this particular K, and in the first index location we are inserting. What is the value we are inserting? Now you can see K value 96.4. Okay. Now I'm calling second time. Getting the point? Now I'm calling second time. Now you can see K value 1 and X value something like 12.4. Now this is K value, it is a K value, it is a 1, so that this particular condition will satisfy. Now if you see this, now what I'm doing is I'm trying to load the parent. So the parent will be 0 index location. Now what is the parent we are going to get? 96 something. So now if you see this 96.4. Okay, whenever I'm trying to click this particular E, it is trying to show as a 96.4. Okay, this is the parent record. Now what is the key we are having? 12. Getting the point. Now if you see, we'll get minus value. Here we are going to get minus value. Okay, I did not copy this. Now minus value I'm getting. The minus value, this condition will not satisfy. This particular condition will not satisfy. Whenever it is not satisfied, it is moving into this. So what is the E value? E value we are having 96.4. Now what I am doing here? In the first index location, getting the point. In the first index location, now I am trying to replace. So observe carefully. This is important. First I will give you the diagram. Okay, 0, 1, 2, 3, 4, and up to the 9 records. So imagine this. So in the 0 index location, now inserted as a 96. We are trying to insert it this particular index location. So we are trying to insert second record. Now what happens internally? Based on this particular line number 664, what we are doing here? Getting the point. What we are doing? We are trying to find out we are trying to reinserting the value. What is the E? He contains this particular 96.4. Now it is going to insert it in the same. Now so far in the 0 and first index location, we are having two values. So if you observe this, if I'm going to show you this ES, you will understand this. If I'm going to show you this, you can see first one is 96.4 and the second one also we are having 96.4. Now you can see, I will expand both values. So now you can see carefully 96 and 96. In the first and like in the 0 index location, first index location we are having same here. Okay, this is important. So now what I am doing here? So parent, what is the parent here? The parent we are getting as a 0. Parent we are getting as a 0. Getting the point. Now what you can understand this particular parent, now it is 0. This loop will not repeat one more time. Okay, and now you can see what is the K value right now? 0. So what you are understanding here, in the 0 index location, what is the value we are passing? The X value, or we can call it as a key. So X and key both are same. Now 12.4. Now if you observe carefully, this value now it is replacing with 12.4. Now you can see one shift operation is completed. Getting the point? One shift operation is completed inside this particular priority queue. Okay, because this is the lowest value we identified. First, we are inserting the zero index location, and 96 is the some highest value. Because of this, we are moving into the first index location. So I will keep this like a indexes information, and we'll try with one more object. Now you can see this is the value is going to replace it. Now if you see this ES, now the value is modified. So first in the zero index location we are having 12, and in the first index location now it is replaced with 96. Okay. Now if I'm going to show you this, so first we are inserting 96. Now the 96 come to the first index location. Okay. And we'll call the one more objective. So this is the index we are passing as a second. And what is the value we are having? The x value 78. Okay. Now we'll see. So k value how much we are getting? 2. This particular loop will repeat here. Getting the pen. So this is basically based on this particular bitwise logic here. It is trying to identify the parent information. Okay, it is trying to identify this particular parent information. So right now we cannot identify how this particular bitwise logic is going to implement it. We need to discuss more onto this if you are understanding this particular 3 greater than operators. Getting the point? So this will call it as a bitwise operators here. Okay, it's going to take some more more time to understand how this operation is understanding internally. What is the k value right now we are having? 2. So based on this, it should get basically 1, but we are not getting the 1. Again, we are getting the parent as a 0. Okay, 0. So in the 0 index location, what is the value we are having? 12 value. So here only the diagram is showing here. So this is the 0 index and this is the first index location. Now if you see, we are going to load 12.4. 12.4 we are loading. After this, we are checking the value. What is the key? 78 something. Okay, 78 to this value. Now we are trying to check with this particular E. Now you can see what happening internally. We are getting the positive value. So whenever we are getting the positive value, any operation we are doing it, we are not doing any operations here because 78 is a bigger value compared to this particular 12. Getting the pen. This is important. Now we are not going to do anything. It is breaking and we are inserting the value. Okay. So inside this ES, the third record is inserted in the second index location, something like 78.3. So here I will add so the 7 to like second index location, something like 78. Okay. Back to here again. I'm going to call for the fourth record. Index is 3, and this is the tx value. Something like here you can see what is the value 45 dot something 2 we are getting. Okay, so k value we are getting as a 3. Now you can see, so one more parent we are identifying it. What is the parent right now? 1 we are getting. Whenever we are getting this particular 1, now what is an object we are going to load? This record. So the 96 we are going to load. So once we load this particular 96, now this E contain the 96 and this particular K containing something like 45 something we are having. Okay, 45 something we are having. Now if you see, this will get to the lowest value, something like negative value we are getting. Whenever we are getting the negative value, then only we are going to do the shift operations here. Now you can see we are loading the E. So in this particular k value, what is the k value right now? 3. So in the third index location, we are trying to store the e value. What is the e value right now we are having? 96.4. Now if you see here, I'm adding 96. Here I'm adding 96.4. Okay, so first one is having the same value and the third index also having the same value. Now I'm trying to replacing with parent. Parent we are having 1. So whenever we are having one more time this particular loop is going to repeat here. Now you can see one more time this particular loop is repeating here. So based on this, we'll try to find out I hope 0 it will return. Parent is now it is returning 0. So in the 0 index location, what is the value we are having? Something like 12.4. So the 12.4 we are trying to comparing with this particular key, something like 78 here. Now you can see it is returning positive value. So here first value it is trying to identify 78 with this particular 96. So it is failed. Because of this, we got a -1. So second value, the same 78 and greater than 12. Okay, now it is satisfied. 78 is a bigger value. So here we are getting positive value. Here we got the negative value. Now, whenever we are getting the positive value, we are not going to do any shift operations here. So this is important. We need to understand here. Now, once we get this particular shift operation, where exactly it is going to update the value. Okay. Right now, what is the index we are having? K. K is the index information. Right now, first here. It is the first. Now, whatever this particular X value we are having, the 45 value, now it is going to replace it in the first index location. Now you see, it is breaking the loop. Now it is coming to the 667. What is the key? Something like 45. This it is going to store in the first index location because the K value we are having right now 1. Okay. Now you can see the 96. Now it is replacing with 45. Getting the point. Now observe carefully how the 96 is replacing the positions here. Position instead of basically indexes here. From 0 to 1 and 1 to 3. Getting the point. So this is the way of shifting the positions here. Getting the point. Now finally I'm going to call fourth record. So the fourth record is, you can see, index is 4. Okay, index is 4. The K value is showing as a 4. And what is the X value right now we are having? Something like a 56.5. Okay, 56.5. Now, again, I'm checking this. It is satisfying the condition. Now, parent. What is the parent we are getting? Again, we are getting the 1. Okay, again, we are getting the 1. Whenever we are getting the 1, so what is the value it's going to load? This 45 value it's going to load. Now, you can see, if I'm going to show you this E, it will contain the 45. Because of this particular parent value, parent is now it is indicating, like, now it is working as a index here. Getting the point. This is important, we need to understand here. Okay, this is important, we need to understand. After this, we are checking the value. What is the key value? 56. Now what is the E value? Something like 45. So it is getting greater value only, because 56 greater than 45, so it is matching it. So once it is matching, we are stopping this. So once we are stopping this, now we need to understand here, what is the K value right now? Something like 4. Now in the fourth index location, we are going to store as a 56 value. So now I will store here 56 value. But compare here, if you compare this, so between we are having 96. It should be replaced here. So we'll see how it is going to replace this. So again, I'm trying to call one more time, or it is not calling. Now you can see. So these are all the values we are having. So far, these are all the values. If you are having any less value compared to this particular 96, it will replace it. Right now, we don't have anything. Because of that, it did not replace the value here. Okay. Now, if we observe what are the values we inserted. So 96 we inserted as a first record, but what happening internally? It is trying to insert as a third 0, first to second, and third index location. Getting the point. And the remaining 12 is inserting in the first 0 index location. Later, the 45 is trying to inserting in the second index location. So how it is working here? The add method internally, it is trying to work on the offer method. So we need to identify how this offer method is going to work. So insert the specified element into the priority queue. Okay, if we don't have any much information here, but we'll go to this particular, where is the queue? Here we are having the queue. Something I will copy into this. So what is the method we are having? How we are getting this? Okay, so here I'm going to move on to the queue, and internally it is calling the offer method. Now you can read this, what happening internally. So it's going to insert element into the queue. If it is possible to do immediately without the violating the capacity restrictions. Here we are checking the capacity restrictions. So okay, it is not going to validate anything here. And here, what exactly it is taking the parameter, and it will return the true value, and it will going to throw in a some exception. But what you need to understand this particular priority queue. So basically, If you are trying to use the comparator, based on the comparator, we can sort the value. Otherwise, it will try to use the particular default sorting mechanism that we are going to use as a comparable. Getting the point? Based on this particular comparable, it is trying to insert the value. Okay. So any questions? So regarding this particular add method, anyone having any questions? So we identified how this the add method is implemented internally. Add method basically it is trying to call the offer method here. Now we are trying to check about the offer method, how it is implemented internally. Okay, so this is one of the important we need to understand here. We'll move on to the another add all method if you don't have anything regarding this particular add method here. So if you are anyone having any questions, so you can ask me regarding this add method. Okay. Now we'll see how this add all method is going to work internally. So to work on this particular add all, now what we can do, we need to create any specific collection class here. So what are the specific collection classes we are going to create here? We identified the linked list and so we'll discuss about the tree set here because see we are not going to use this, but we are identifying the how these particular classes are implementing internally. This is important. This particular code we are not going to use anywhere. So just for more understanding how it is going to use internally. If you are trying to create any custom the collection class, this particular code is going to useful. You can check the code how they are implemented and how you can write the custom collection classes. Getting the point. If you are understanding the internal structure, we can easily understand which collection class is the best for use. So we can easily understand and we can go for the specific collection class. If I'm not providing the implementation, the what is the method is will do. If these particular methods will do the same operations. So far, whatever the method we discussed, this particular collection related method, it will try to implement in the all the collection classes, the method will do the same operation. But the internal implementation is different. Each and every class, how it is implemented internally, that is important here. Getting the point. So because each and every, the purpose of this method is same. Because the add method will do the insert the record, size method will do the capacity, how many elements are inserted, isEmpty method will do the so checking any objects are inserted into the collection. So iterator, it will try to repeat the value one by one. But the repeat logic, how it is implemented and how we are checking this isEmpty internally, that is important here. Okay, back to here. Now I'm going to create.
So suppose add same record, it will announce or not?
Good question. But here, anything we are checking here, because here we are not using any the like key equal condition or hash code logic. Here we are trying to store the element into the this particular object array. Getting the point. So for example, if I'm trying to store this particular value at the last, the 96 I'm trying to store one more time. If I'm trying to call this first without this, we'll see any issue we are having. So here we are able to see 96 as well as same 96 here. Getting the point. Here we are not checking any object equal here. Getting the point. Just we are checking the order. If the less value we are having, we are trying to modify. But if we are not having anything directly, we are trying to inserting in the next order. Next order. So whenever we are having the object to equality, then we can identify, we can insert the duplicate value or not. Only in the set related example, we cannot insert the duplicate, but remaining cases we can insert. Because array list is doing the object array. and linked list is in the node concept, and hash map internally they are trying to check with like equal and hash code mechanism, and the three classes will work on the same. Getting the point? So the linked has set and tree set. Tree set we identified is going to use on the comparator. Is going to use on the comparator. So if we are having the same value, now it is replacing the value. So this is we discussed in the last session. Let me go to this particular tree set one time. If you are having the same value, like same key, what it will do? I'm going to call add method. Put method we are calling. Okay. It is a declaration. We need to move on to the implementation here. Which method is calling multi-map? Sorry. Multi-map. We'll call this. So we are at a tree map. Now we'll call this comparator. Now you can see if you observe this, what we are doing is, if it is a comparator here, now this object is not going to, like this object will satisfy the condition. So once it is identified this particular condition, here we are checking the value, less than value or greater than value. Whenever we are having the same keys, like whenever I'm trying to insert the same value one more time, this if condition and else condition will fail. We are trying to move on to the else section. Here what we are doing is, we are trying to replacing the value, not the key. Getting the point? This is important. Only we are replacing the value. So it is going to happen inside this particular tree set. Only in the set related section we are not going to insert the duplicate here, but remaining cases we can insert the duplicates. Okay. So come back to here. Now we discuss about this particular duplicates here. Now I am moving on to the one of the important, the add all method, how it is going to call. And the tree set, we need to import this because we are inside the different package. So we need to import this particular, the tree set class. So then only compiler will understand how it is implemented internally. Tree set here. And here only the first place I will add the TS related some records. Okay, observe carefully 78.1 I'm trying to store, and we'll try to store multiple records here with help of different value. ts.add something like 96 already is there. We cannot go for the 96, 85.7. Okay, so 3 records. Let me insert the 4 also. 4 records we are having something like 65.7. These are all the 4 records I'm trying to insert into this particular tree set. Tree set we already discussed here how it is going to insert here. And come back to here, I'm trying to call this particular priority queue dot add all. Here I'm trying to pass this particular TS. So this is important. We need to understand how it is implemented inside this particular priority queue, this add all method. Okay. Now we'll see, before going to debug the code, first we'll understand how it is implemented here. Okay, how it is identified. So we discussed about this 12 because we are trying to do the some shift operations here, 45, 65, 78. Again, we are checking this particular 56, 94 something. We are doing this particular operations here. Okay, this is we need to understand. So after this, I hope first record like what is the value 96. 96 started, 12 and 78. Okay, this 78 is different. Okay, we'll see how, because if you see this is the first record we inserted and it is come to the around fourth, like third index location, and the same way This 12 we given, now it is move on to the first index location. We need to identify how this particular priority queue internally it is implemented. Because we based on the comparator, it is modifying the indexes information. I will call this add all method, and now we are in the abstract queue. So it's checking the two conditions. First one is null pointer, second one is illegal argument here. Getting the point. After this, we are calling the same add method. Whenever we are calling this particular add method, now what we can do, we need to put a breakpoint where we are at priority queue. Where is the priority queue? We'll see inside the priority queue, we are going to call offer method, shift of method, comparable, and here, yeah, 659, we are having the breakpoint here. Now directly, I am going to call add all method. So add all method. Now observe carefully. Directly, we are moving into the 659. I will stop this right now. Yeah, I will go to the same priority queue, and here I'm going to put a breakpoint. Now, the basic, whatever the priority queue related, the add method we call, and we insert the value. Now, if you see this object yes here, we can easily understand how these objects are inserted. Okay. Now, if you see this, now what we can understand here, so 12, 45, 78, 96 and 56, finally the same 96 we are having. So this is the order we identified. After this, now we call the add all method. Now if you see this, here we are calling the offer method, and here we are calling the add method, and finally we are calling this particular add all method. From the add all only, the whatever the code we are showing right now, the method is executing it. So this is the line number 187 it is called. And what is the value we are passing this particular E? Now if you see this, here you can see the E value, something like 65 we are passing. Okay, 65 we are passing. So far, how many elements we inserted here? So if I want to identify size, we can check here. Size we can check this, like 6 records we inserted. 6 record we inserted. I hope this is the index we are having 6 here. Now we'll see k is less than 6 here. Now the parent, what is the parent we are getting? Something like a 2. Okay, something like a 2 we are getting. Whenever we are getting this particular 2, now what you need to understand, in the second index location, what is the value we are having? Something like 78.3. The 78.3 we are loading here. Now if you see this inside the E, we are having 78.3. 78.3. So this is the value we loaded. And now we are comparing. So this E contains 78 and K containing something like 65. So 78 is a bigger value. Now if you see this, what is the value we are getting? Negative value we are getting, because 78 is the biggest value, 65 is a less value. Now whenever it is getting the -1, now what I am doing here, the 78, okay, whatever this particular 78 in the 6th index location, now I am trying to replace. So right now, what is the value we are having in the shift index location? Now if you see carefully, any value is there? No value. Getting the point? As of now, we don't have any value. So now we are going to insert this. So now if you see, the new record is going to insert it here. Getting the point? New record is inserted. It is highlighting in the red color. We can identify. This is the first record here. Okay. And what I'm doing? So what is the parent right now? 2. So this particular parent is now passing into this particular case. So 2 more times this particular loop will repeat here. So first repetition is completed. Now we are trying to repeat the second time. Now again we are loading the parent. Now if you can see, 0 we are getting. Okay, we are getting 0. In the 0 index location, what is the value we are having? Something like 12. 12.4. So this particular 12.4, we are trying to set into this particular E. After this, I'm comparing. So after this, I'm comparing. What is the key right now? Something like a 65. 65, I'm going to compare with this particular E. So we'll get the positive value. Whenever we are getting the positive value, so this particular loop is breaking. So once it is breaking, now what you need to understand, what is the key value right now. The key value is 2. Getting the point? The key value is 2. Now, in the second index location, the value is going to replace here. What is the value is going to replace here? So far, in the second index location, we are having 78. Now, if you see this, in the sixth index locations also, we are having same value. 6 and second, we are having same. Now, you can see. So, this value, now it is replaced with 65. Now you can see, now it is replaced here. Now I'm going to open one more time. The second is now replaced with 65. And the 78, now it is moved to the sixth index location. Getting the point. Now the order is replaced here. So this is the way of calling internally the add all method. Again, internally it will call the add method for based on this particular compare method. If it is a positive value, it will insert the value. If it is a negative value, it will try to modify the index location. Okay, this is important. So this is all about the add all method. It will try to call the around 4 records or 5 record be inserted here. Okay, any questions regarding this particular add all? Add all basically internally it is calling on the same add method, but only the difference here it will try to call the with the help of this particular loop here. So inside the loop only this add method is going to call. So any questions regarding this add all method? Okay, now we'll move on to the another important method what we are having. So this is the iterator is very important. We'll discuss this particular iterator. Now after this we'll move on to this particular toArray. toArray is a simple method. Just internally it will call the object array based on the size, and after that it will call the iterator. Most of the cases we are going to call this particular iterator. So now you can see pq dot iterator I'm calling. Okay, directly we are going to call in the debug mode. We'll identify how this particular iterate is going to implement here. I'm going to remove this. The breakpoint is no longer needed. Now finally, I'm calling the iterator. Now we'll see how it is going to implement here. Now inside this particular priority queue, just we are returning the object. So which object we are returning? This is important here. What is an object we are returning? Something like ITR. ITR where it is implemented here. So this is the one of the private final class ITR. This private final class is internally is implementing from this particular iterator. Okay, this is the class, and this particular class we need to understand. This we need to understand how it is implemented. The two methods. What are the two methods here? Has next and next method. Okay, observe carefully. We need to identify how these methods are implemented. First is a has next method, and this is the next method. Whenever we are calling the as next here, this particular code is going to call, and whenever we are calling the next method, this particular code is going to call. Okay, we'll see how this particular codes are going to execute. And before this, any constructors we are having, so we don't have any constructors here. Right now, we don't have any constructors. Just it is a default constructor we are calling. Now we identified. So later, I will put a breakpoint on this as next, and I will put a breakpoint on this particular next. We'll see how it is implemented these two. So coming back to this, and I am going to call this particular has next. So this has next is calling from the where? From this particular toString method, because we are trying to print all the records. Getting the point? Here we are trying to print all the records. Now if you see, it will go to the println, and inside the println we are calling the string dot value of, and from the string dot value of we are trying to call the object dot toString method. Okay, object dot toString. Whenever we are calling this particular toString method, now it will go to the abstract collection. So now you can see this is the abstract collection we are calling, and inside the abstract collection we identify just now the iterator how it is implemented. We are calling on the has next. So now we need to debug this particular has next how it is implemented. So this has next, the breakpoint is called here. Now we are trying to identify what is the cursor right now? 0, because this is the default one. So far we did not inserted any value inside this particular cursor. Now, what is the size? Size we are going to have most probably, here I'm not getting. So we'll see whether I can get here inside this. We are having this. These are all the values we are having. So around 10 records. Now you can see size is 10. Okay, size is 10. Now if I'm going to point out this, now I'm getting as a true. Now I'm getting as a true. If you are not interested this, what we can do, create a one expression here. Here we are having the expression section. Okay, inside this particular expression, click on this plus icon. This particular plus icon will do the one more pop-up here. Now you can see here. Now whatever the value we want to use, now you can write cursor less than and size here. And click on this particular OK. So here you are going to get the value. So where I'm getting the value? Here. This particular line I'm getting the value. First one, so this will call it as the expression and this is the original value. This is the way of identifying the particular expression. So whatever the expression we are having so far. Getting the point? This is the important information we need to understand while debug this particular any one of the codes here. Okay. Now back to here, we identify the cursor is true. Once it is true, now what is doing internally? What is doing it? So this has next will return true because our operator we are using. Either this condition should satisfy or this particular condition should satisfy. The first condition is satisfied, no need to check any condition. Okay. Now we identified has next we are having elements here. Now I'm trying to click on this particular F8 here. So directly one more time we are calling the same has next. Okay, so we'll see this. Now it is completed. Now we are coming back to the next method. How it is calling this particular next year? From where we are calling the next year? Here we are calling inside the abstract collection because we are inside the toString method. This has next because here we are using the not condition. Because of that, it is written false here. So coming back to this, so it is executing this, and finally now we are trying to load the correct value. So what is the correct value we are trying to load with the help of this particular next? Now we need to debug this particular next to understand how this particular iterator is implemented internally. Okay, now understand here. Expected mod count 10, and what is the mod count? What is the mod count here? Now if you are not interested, do the Control Shift I. So it is returning false. So this condition is returning false. Okay, now we'll see this. Now we'll see this. So this just now we discuss here cursor less than size. This is return true value. Same way this particular value also will return true. Once it is returned true, now what I am doing here? Here Q. Getting the point? This particular Q will contain all the objects here. If I'm going to expand this, now you can see so far whatever the record we inserted, all the records are going to store inside this particular queue. So 9 record we inserted here. 0 to 9 records are inserted. Okay, now we identified. Now if you see what I am doing here, what is the cursor value right now? 0. Because if you see here we are using the post increment. Getting the point? So this is important. Cursor post increment will do the different and pre increment will do the different operations here. So because of this particular post increment here, first we'll load the value from this particular queue and will set into this particular last RET variable, and later it will increment this particular cursor value. Here is doing the three operations. First, whatever the cursor value we are having, the value it is trying to set into this particular last RET, and getting the point. First it is doing this, and later based on this particular cursor value, it is trying to load from the queue array. It is trying to load from the value from this particular queue array, and it is trying to set into, it is trying to return. After this, it will try to modify the cursor value. Okay, these are all the three operations. Now if you see this, so once I come out of this, okay. So once I come out of this, we don't have an option here because directly we are trying to return this. We could not identify, but right now cursor value 0, it will become 1. After this particular line number 537 will increase, like will come out of the line number 537. Okay, What is the value we are trying to load? Something like what is the value which is resides inside this particular zero index location, because cursor value right now 0. Okay, now you can see the value trying to return. What is the value we are getting here? Something like here we need to identify this element here, 12.4. Okay, 12.4 we are getting the value. So now second iteration. Now again we are checking this. What is the cursor right now? 1. How it is modified here? Because here we are using this particular plus plus. We are using this particular plus plus. It is a post increment. Once the operation is completed, later it will update the value. Getting the point? Later it will update the value. So now the cursor is replaced with the 1, and 1 less than size around 10 we are having. So still it is satisfy the condition. Still it is satisfy the condition, and we are checking this. Now we are calling the append method, and one more time this particular loop is repeating. So next method we are calling. So these are the condition will satisfy because cursor is having 1 and size we are having 10. Okay, after this, now what I'm doing here, again I'm calling. So after this particular loading the value from this particular queue, cursor value will update. Now cursor value is 1. Now in the first index location, what is the value we are having? The value it is going to load. Later the cursor value will update here. Okay, this is the way of loading the all the values. So this is the has next and next method is implemented inside this particular priority queue. Getting the point? Now you can see it is trying to call multiple times the has next and next method. Now if I'm trying to remove the breakpoints, this is the objects are loading. Okay, this is important here how it is implementing internally. So any questions? Anyone having any questions regarding this particular iterator? Whatever the iterator we are calling it, the same iterator it is implemented inside this particular abstract collection, because we are calling the toString method from the abstract collection itself. Any questions regarding this particular iterator? Now I'm trying to call this, and after this we'll call the same while loop here. Iterator I'm going to call iterator dot has next I'm going to call, and later I will print this println iterator dot next method. So I'm giving some space. So finally I'm going to comment out this, so that same value, whatever the same value we got right now, the same value we are getting here. So instead of doing this, we'll try to come up with a comma. Okay, we'll try to come up with this particular comma here. So 12.4, 45.2, 65 something up to the 148. Okay, this is the way of calling this particular iterator. And later, what we need to understand here, the particular two array, whatever this particular two array we are having, we need to understand. So basically, it is a simple code only. We can easily understand here how it is implemented internally. So pq dot two array. Now I will show you the code how it is implemented first. Now what we are doing is we are trying directly we are copying here. So it is a simple one. So here we are not using any the loop concept and loading the values and setting into this priority queue. But simply what we are doing is we are trying to call the arrays.copy of value. This array.copy of method we already identified multiple exam. Whenever we are discussing the array related, so we already familiar with this particular method. So no need to discuss anything here. So still anyone having any questions regarding this particular two array method? So do I need to explain how it is implementing this particular arrays.copy of method internally? Okay, anyway, we'll see one time how it is implemented here. This is the static method we are having. Now you see we are trying to pass the original based on this particular length. Now you can see one more copy of method we are having. So simple. This is the original array we are passing, and this is the length we are passing here. Now what it will do, based on this particular length here, okay, based on this particular length, it is trying to create the object array, and whatever the values we are having, whatever the values we are having, now it will try to store into this particular a newly created object that is called new type. Getting it? So this is type, the new type we are going to store as a element here. So by calling this system.array copy, it will copy the original array into this particular copy. Because this is the destination. Now you can see this particular source object here, and here we are having destination object. Getting the point? So source object, whatever the source object element we are having, we are trying to copy into this particular destination. This is, we need to understand how it is going to copy internally. It is a simple method. No need to discuss more on this because we are already familiar with this particular array related method. So this is the simple way of calling the arrays.copy of method. It will convert the priority object into the object array. Again, once it is converted, we can call the object array to use this particular methods here. Okay. After this, we need to discuss about the add method, remove method. So to understand this particular remove method, remove also, it's a simple method. What it will do, it will try to remove the element from the particular index location. So we'll see how this particular remove method internally it is implemented. So I'm trying to call remove method. We are having two remove method. So first remove method will not take any parameter. Second one is trying to take the parameter. First we'll see without the parameter how the value is going to remove internally. Okay. Now if I'm going to provide this implementation, it is calling the particular pool method. Okay, internally it is calling this particular pool method. Now if I'm going to provide the implementation of this particular pool, linked blocking. Okay, we'll see this. Okay, queue. So I thought it is not having. Okay, we'll see from the debug mode. We may identify how it is going to work internally. Because some jars I don't have, because of that we could not identify the particular code, how it is implemented internally. Now finally, I'm trying to call this particular remove method. Now you can see we are moving into this particular poll method. Again, I'm trying to call this. So here, this method is implemented inside this particular priority queue. Okay, so what we need to understand this. First, we are having two reference variable here. One is the object array and another one is a result. And here we are trying to use the if condition. So this if condition is very important. This condition we are doing the initialization as well as condition. Okay, initialization as well as condition we are doing here. Now we'll identify how this initialization will do the first. The initialization, if you see, whatever the first record we are having, whatever the first record we are going to get, now I'm trying to set into, okay, sorry, this queue, now it will try to set into this particular ES, and later, later, whatever the first record we are going to get, the value we are trying to set into this particular result, and if this result not equals to null, this particular condition will satisfy. So here, first operation what we are doing is, whatever the queue object we are having, now I am trying to initializing into this particular ES. First step. And the second step, whatever the zero index location. The zero index location, whatever the record we are going to get, the record I am trying to set into this particular result here. So result. And the third condition, this is important. If this particular result not equals to null. These are all the three operations is doing internally in the line number 590. Now we'll see what happens internally. If the condition will not satisfy, it will go to the outside. Now we can see it is satisfied. Now what is the result we are having? First record 12.4. Okay, what is the ES is contained? All the objects here, all the objects we are having. So far, whatever the object we store, all the objects we are having. Getting the point. Now, what it is doing here? So first, I already load the first record here. Inside this particular result we are having, we loaded the first record here. After this, now if you see this, we are trying to call the mod count, and later inside this particular ES, I am trying to decreasing. This is the pre-decrement operator. This is a pre-decrement operator. So right now, how many size we are having? Let me remove the expressions here. Again, we'll add one more expressions here, something like size here. Simply we can add the element like size, and click on this particular OK. It is returning 10 value. Here you can see inside this value section, it is returning as if 10. This is, we'll call it as a expressions here. And now we identify. So first what it will do, it will decrement the size. Now the size will become 9. Once the size will become 9, we are trying to set into the n value. After this, now what I'm doing, I'm trying to load the ES. So in the ES, what is the ninth record we are having? Any record we are having? So ninth record we are having something like 148.6. Okay, now we'll identify the X value is going to load as a 148 or not. Now if you see the X value, same value we are getting. Whatever the 148 we are having, it is trying to load. Now you can see N value 9. The result we are having 12.4. Now the ninth record 148 says the X value also same. Okay, the X value also same. If you understand more, you can click on this 148.6. Now it is loading the last record. So here we are having first record. In the result we are having first record. In this particular X we are having last record. Now what I am doing here? What is the N right now? N basically 9. N basically 9. The last record. Now what I am doing here? I am trying to make null. Okay, I am trying to make this particular null here. Now, what you understand, this particular ninth record will replace it with a 9. So now you can see whenever I'm doing it, now the ninth is repeating as a null. So you can see the yellow color we are getting because the value is modified now. Okay, now observe carefully. N greater than 0. So this condition will satisfy because n value 9 we are having. The comparator we did not provide anything because we are okay. Comparator is null here. When the comparator is null, we are calling on the comparable. So this comparable, it will try to reduce the values and it will try to give you the based on the size here. Now we'll see how it is doing internally. So now you can see this is the some big code they implemented here because they are trying to do the again left and right operations. Okay, left and right operation they are trying to do the internally. So same code, what whenever we are trying to inserting, the same code is implemented, and after deletions also it is trying to do the same operations here. Getting the point? It is trying to do the same operation. Now you can see we are loading the k value, and what is the off value we are getting here? Something like 4, because the n value we are having 9 here. Okay, we are trying to load this particular off value as a 4. After this k value, what is the k? K value basically 0. So k is a 0, half is a 4, condition is satisfied. Now we are checking the child record. So what is the child record we are going to get first? And based on this, again we are loading the first record and we are trying to find out the child plus 1 right record. Now we are checking this, and based on that again we are doing the comparison and we are trying to load the all the operations here. Okay, so what is the operations, how we implemented the same, the add method, the code same for this particular deletions also doing, but a little bit some changes we are having. So now, so debug this particular code, you can easily understand how this particular remove method is understanding. But finally what we need to understand, whenever we are calling this particular remove without the parameter, the last record is removed. Okay, the last record is removed here. So this is okay. So now what you need to understand here, this is important information. Whenever we are calling this particular remove method, we need to, we are trying to remove the last record here. Okay, and after calling this remove, if you are having one more specific method, pq dot remove method, if you are trying to providing the parameter, directly the particular object is going to remove here. So let's see what is the value we can remove. So we are having two records. So 96.4 we are having two records. We'll try to remove this particular 96.4. Okay, now I will call the same the remove method here in the debug mode. Now we'll see. So this remove method I'm calling, and finally it is calling the double. We'll go to this one more time. So index of. Now you can see what I'm doing here. I'm trying to find out the index of here. This code is different. Okay, so for the remove method internally, it is called the pull method. But right now, we are not calling the any pull method. We are calling first load of this particular index. We are passing the objective, and we'll try to load the where exactly this object is resides here. Now, if you see this, if the O is not equals to null, we are trying to load the all the Q element into ES, and we are trying to repeat the loop. Simple logic. Okay, there is no much code here. We are trying to do the loop here, and we are checking the object information. If the object is fine, we are trying to return the I. Now you can see, so not matching, second record also not matching, third record also not matching, fourth is not matched, fifth it is not matched, and sixth is matched. Simply it is identified. So I value 5. So what you can understand, I value 5. Getting the point? Once I value 5, we are calling this particular remove it method. Now we'll debug this remove it method. Again, we are loading this particular queue because right now we are having the index here. Right now we are having this particular index. Now you can see we are decreasing the size, and S is equals to I. No, this is not matching here because S is containing 8 I4 and 9. Now you can see S is having 9 and I value we are having 5. So both are not satisfying. If it is not satisfying, simply going into the else section. Now you can see some shift operations we are doing. This value is going to remove 148. Okay, this is the last value we are having. This is the last value we are having. Now we are doing the shift down. Okay, we are doing the shift down operation because this value we are going to remove, and it will try to replace the values. So there is no the much code here. Just once a value is removed, it will try to do the some other shift operations here. Now if you see this, we are not using the comparator. We'll go to the comparable. Now again same code. Okay, whatever the code we identified earlier, same code. This code, now what is doing internally, it is trying to do the shift operations here. When the middle element or first any element we are going to remove, it will try to do the shift operations here. Getting the point? For example, we are having this particular collections here. So 1 or 2 something, whenever we are trying to have this, if I'm trying to delete this particular object, this object should be replaced to this particular location here. This is the method is going to do by this particular shift done comparable here. Okay, so you can debug this particular methods here. You'll get understand how it is implementing internally here. This is the one of the important information we need to understand. The another remove method, how it is going to work internally, and the another method we are having remove all methods. So this method we'll discuss in the tomorrow session. Okay, so far we discussed the add method, add all method we discussed here, iterator we discussed here, and something like the two array and remove and one more remove method we are having. These are all the two different remove method we are having. We discussed this particular remove methods here. Okay, so any questions? Anyone having any questions regarding this particular today's session? Okay, so if we don't have anything, so we'll continue tomorrow, the continuation of this particular priority queue. So once it is completed, we'll shift it to like a map related example. So most probably I'm thinking, so tomorrow we'll start the map related because less concepts only we need to discuss in the map here. Okay, we'll continue tomorrow.